This video is about differential rate law calculations. So this first problem says 2a plus x2 yields 2ax. The reaction is studied, we get this data, and we have 3 trials. We have the differential rate law. Rate equals k times the concentration of A times the concentration of x2, and we want to calculate the value of k. So looking at this problem, since we have the rate law, we can just pick some values and plug them in. You can pick trial 1, 2, or 3. Any of those is fine. But I'm going to pick trial 1. And I'm going to use this data and plug it in to rate equals k times the concentration of A, concentration of x2. So I'm going to take my rate, which is 0.44. So 0.440 equals k times, let's see, concentration of A is 0.75 times concentration x2, so times 0.28. To solve for k, I'm first going to multiply 0.75 times 0.28. And that gives me 0.21, and then it's times k equals 0.440. I want to get k by itself. Right now I'm multiplying by 0.21. To kick it out, I need to divide by 0.21. Divide the other side as well. 0.44 divided by 0.21 will give me k. And that equals 2.095. I want 3 sig figs, so I'm going to round this to 2.10. That's my value for k. But now I need the unit. Overall, this is a second order reaction because A is first order and x2 is first order. So I need the unit for k for a second order reaction, and that's m to the negative 1, s to the negative 1. So that's my unit for k, m to the negative 1, s to the negative 1. I'm going to look at one more example. 2N2O5 yields 4NO2 plus O2. I have the differential rate law. Rate equals k times the concentration of N2O5. And I'm going to calculate a rate this time. You can see that blank box for trial 2. I'm going to approach this in 2 different ways, and either way you choose to do this is fine. I'm going to compare the concentration in these 2 times and the rate in these 2 times to figure out what it should be. Well, I know this is first order. So when you go from 0.35 to 0.7, that doubles. So the rate should also double because this is first order. So I can just figure out what's double 0.0720, and that's 0.144. And that's my rate when I have 0.7 as the concentration. There's another way to do this though, and that's to solve for k using the data from trial 1, and then use k to solve for rate in the second trial. So I'm going to use the first trial, use the rate 0.0720 equals k times 0.35, divide by 0.35, and that gives me that k is equal to 0.2057. And the unit on that is inverse second. Second to negative 1. So now I'm going to take k and plug it in for rate equals k, 0.2057, and I'm going to use this other concentration, 0.7. Multiply 0.2057 times 0.7, and you'll get just about the same thing as before, that rate is equal to 0.144, and that's molar per second. So either way you approach this is fine to get the rate for that other trial.